Problem number 10. Solve for x and y. So what are we solving for? What are x and y here? They're angles. Okay, so very often you're going to have to figure out, well, is x trying to represent the length of the side, or is it representing the length of an angle? Okay, it's helpful that we see one angle measure in here, 31, and it's wedged in between these two sides. Just like x is wedged in between these two sides, and y is wedged in between these two sides. So when you see a letter that's stuck right in between two sides and wedged inside the angle, it's referring to the angle measure. Well, we know that the sum of the angles of a triangle is equal to 180. So let's go ahead and use that. See if we could solve this triangle. So that means 31 plus x plus y equals 180. Just like we did in the last problem. The only problem here is that how are we going to solve for x when we don't know y? Okay, so we've got a bit of a problem. We have two variables that are unknowns in one equation, which means we can't solve for the variables definitively. We need more information. Well, take a look at this drawing and tell me. Usually there isn't information given for no reason. If we're given additional information, we need to try to figure out how to use it somehow. So in this triangle, notice we've got one hatched line on the left side, one hatched line on the right side, and that is shorthand for telling us that the length of the left side is equal to the length of the right side, that these two sides have equal measures. So what kind of triangle is that then? An isosceles triangle. An isosceles triangle is a triangle which has two equal sides. But what did we prove above about an isosceles triangle? Specifically about its base angles. Take a look and review what we proved. We proved that the base angles of an isosceles triangle are equal or congruent. The two measures are equal. What are the two base angles of this isosceles triangle? Well, to figure that out, we have to look at find the vertex angle. Well, the vertex angle is opposite the non-equal side. That would be x. X is opposite the non-equal side. The base angles are opposite the equal sides. They would be the other two angles here in this diagram. They also happen to be opposite the equal sides. That's another characteristic of base angles. They're opposite equal sides. So 31 and y are the two base angles, and we know the two base angles have equal measure. So y must be 31 degrees. So let's go back to our equation here. 31 plus x. Now instead of just y, we can put down 31. And now we can solve this. So 31 plus 31 is 62. So x plus 62 is equal to 180. We subtract 62 from both sides, and we get x equals 118 degrees. So we are done. X is equal to 118 degrees. And y, I should mention, because we're supposed to solve for both x and y, we already pointed out that y is equal to 31 degrees because it is one of the two base angles, along with 31 degrees, along with the other one. Okay. Good. Now let's go to this next problem, solve for x. Well, this is the first time we've seen a triangle where we don't have a label for this angle over here. But does that really matter? We know that the base angles are equal. We know here that x and this angle, whatever it is, are the two base angles because they're opposite the two equal sides. So whatever x is, it's got to also be equal to this base angle over there. Because base angles of an isosceles triangle are equal. So let's go ahead and make our equation 98 plus x is equal to 180. And we just need to solve this for x. We get 98 plus 2x is equal to 180. Subtract 98 from both sides. We get 2x is equal to Well, I'll do this the long way. I'm sure you could do it better with your calculators. 2x is equal to 82 degrees. X is equal to 41 degrees. Okay, so we've solved for x, and that's our answer.